we have to solve this problem. A man is standing on a roof that is 11 feet above the ground, and he throws a ball into the air with an initial vertical velocity of 40 feet per second. The height of the ball, t seconds after it is thrown into the air, is given by h is equal to negative 16t squared plus 40t plus 11, where h is measured in feet. Find the maximum height of the ball before it hits the ground. Now notice I've made a simple diagram of the man standing on the building and throwing the ball into the air. If you'll notice the projectile motion, it looks like an upside down parabola. And in fact, the function itself, h equals negative 16t squared plus 40t plus 11, is an equation that if you graphed it would give you an upside down parabola. Well, we know that the maximum of any parabolic function happens at its vertex if the parabolic function is upside down, or another way of saying that is if the leading coefficient is negative. Of course, if we have an upside right parabola, it's a minimum that happens at the vertex. But in this case, we clearly have a maximum that occurs at the vertex of the parabola. So to find the maximum height of the ball, I have to use my vertex formula or my vertex shortcut. Now, one thing about this, the vertex shortcut formula that we use, normally it's x is equal to negative b over 2a. I'm using t is equal to negative b over 2a because in this problem, my t's are acting as my x. So t is equal to, remember, a is negative 16, b is 40, and c is 11. So t equals negative b, so that would be negative 40 over 2 times a, where a is my negative 16. That would be negative 40 over negative 32. That's a fraction that I can reduce to 5 over 4. Now, if you want to, you can also use a decimal. 40 divided by 32 gives you 1.25. And as long as you're not rounding, that's fine. I kind of prefer my fractions. I can work faster with fractions instead of having to reach for a calculator. Now, the one thing you have to remember is that this formula only gives us half the vertex. And in this case, it's not giving us the half that we're finally looking for. T represents time. So what we've basically found out so far is that 5/4 of a second, or again, if you want to talk about decimals, 1.25 seconds after the ball has been thrown out of into the air is when it will hit its maximum height. But that does not tell me how high the ball actually traveled. To find the height, what I have to do is take my t value and plug it back into the original function. So the height, 1.25 seconds, or again, I'm going to use 5/4 seconds. After I throw the ball, or after the man throws the ball into the air, will be found doing this calculation. And again, the reason I'm doing this with fractions is because I don't have a calculator, and it's much easier for me to square 5/4 and get 25 over 16 than it would be for me to square 1.25. 40 times 5 over 4 plus 11. And this problem is really quite nice because notice that the 16 cancels with the 16. Make sure we don't drop the negative, so I'm getting negative 25. 4 goes into 40 10 times, so plus 50 plus 11, which ends up being 36. That 36 is 36 feet. 1 1/4 second after he throws the ball into the air, the ball will be 36 feet off the ground. So the maximum height of the ball will be 36 feet.